Hi, this is Sambasam, Assistant Professor, Business College of Technology in the Department of Mechanics Engineering. I would like to discuss about the continuity of the previous two topics. Right? So this time we are going to discuss about the new power plant, nothing but a steam power plants. Before going into a presentation, I would like to share that one of the key points is that how the steam has been evolved in the current turbine power generation process is going to we are going to discuss here. So I like to share the presentation, which is going to be an topic we are going to discuss nothing but a steam power plant. So give me a moment of how it has been done. So the steam is used to drive steam engines and steam turbines due to the various reasons. Especially the key reasons I have been listed below is the steam can be raised quickly from water. It does not react much with materials. It is stable at temperature is required in the plant. This is how it has been developed. So it has a various layout of a steam power plant, that is nothing but fuel coil systems, air fuel gas injection, feed water and steam flow circuit, cooling water flow circuit. So as I said that earlier, this is how the coal ash circuit has been developed from the coal derivative, coal unloading, coal preparation. When the coal is get it from the external vendors and the coal is unloaded in here, once it has been unloaded, the coal is prepared and it is transferred into a cold storage system where the in-plant handling system has been taken into consideration of how it has been handling, and it has transferred the raw material of coal into a boiler furnaces. Once the boiler furnace has been transferred into an ash handling, when it has been boiled, there will be ash has been generated. Those has been handled by using an ash handler, and finally those ashes are being transferred to an ash storage devices. Then, as I said that earlier, right, the coal from mines is delivered by ships, rails, or trucks to the power stations. So the coal received at the coal yard, the coal is used by crushers or breakers. Then the coal size, the size converted in required size. Those sized coals is stored in a cold storage places. So from the stockyard, the coal is transferred to the boiler furnace by means of conveyors, elevators, etc. The coal is burned into a boiler and ash is formed. The ashes coming out the furnace will be too hot to handle, and it also a dusty in nature and also accompanied by poisonous gases. Those ashes transferred to a ash storage and storage particular area where generally the ash will be quenched to reduce the temperature and also the dust content. So then we are moving to an air flow gas circuit. So the air preheater has been available where it has to boiler where the superheater is generated used and the transferred into an economizer and then again to air preheater. So once the air has been heated, the dust has been collected through an ID fan and they are used and transferred via chimney. Similarly, the air has been taken from the atmospheric, then it has been transferred to an FD fan, then used for preheater. This is how air fuel gas has been combined into a mixture and then transferred the values. So the air is taken from the atmosphere by the action of FD fan. It is passed through an air in the preheater. The air is preheated by the flue gas in the preheater. Then the preheater air is supplied to a furnace to aid the combustion of fuel. So, due to the combustion of fuel, the flue gases are formed. The flue gases from the furnace passes over the boiler tubes and superheater tubes. These the flue gases passes through economics to heat the feed water. After it passes the dust through a dust collector, it is then accessed to an atmosphere through chimney, and then comes to an water stream circuit. As the water stream, there is a condenser where the condenser pump is used to transfer the condensed water into an turbine. Similarly, the hot well is transferred through a feed pump, then through an economizer where the material has been purified and then transferred to from boiler. The boiler heats the water and then transferred into a superheater. Then it is transferred into turbine. The so it has been take place. So the water is preheated by the flue gases in an economizer. The preheated water is then supplied to the boil drum. Then heat is transferred to a water by burning of the coal. Due to this, water is converted into a steam. Then the steam is raised in a boiler, is passed through a superheater. It is superheated by the flue gases. Then the turbine generates to produce electrical power. The expanded steam is then passes through a condenser. In condenser, the steam is condensed into water and then recirculated. Then cooling circuit, as I said, that the cooling circuit is a Exhaust steam came into condensed water, water makeup water, then cooling tower is that where the radius supply is flowing. Once and the cold water is transferred into a pump through a condenser. So the exhaust steam from the boiler turbine is condensed into a condenser. In condenser, the cold water is circulated to condense the steam into a water. Then the steam is condensed by losing heat content to the circulating the cold water. Hence, the cold water is getting heated. The hot water is then taken into a cold water cooling tower. In cooling tower, the water is sprayed in form of droplets through nozzles. And the atmospheric air enters into a cooling tower from the open top opening of the opening provided at the bottom of the tower. Then the cold is again circulated through a pump, condenser, and cooling system. Some amount of water may be lost during circulation. Hence, the makeup of the water is said to point of my means of. This is how the different technologies or different working conditions of an steam power plant is explained. In the next video, we are going to discuss about how it has been working conditions and what is the required and what is the merits and demerits. Till that, bye bye. Thank you.